we just show you some options to work with Azure IoT Hub. It's up to you. It depends on the workflow. So you can choose the options. As you can see that we already create the device from Azure IoT Tools in VSCode, right? And now it's time to connect the real device to Azure IoT Hub. So up here, I also have my ESP32. So this is the device, right? Yeah, this is the board that actually we use, and I'll connect to my laptop there. I haven't show you from the Mac. Let me pull out my terminal. If somehow later you work with Mac, then you need to check whether it's connected or not using this command. So you check the device, right? Is it connected or not? So as you can see in my machine, there are some USB serial device there. So for example, if I unplug the board, then you can see there are only 3, right? So if I plug it again, and there are other serial devices. For this device, this one should be used if using Mac. Later, in the source code that you download, you will have this project, and I already put it here. So in platform.ini, you put the monitor port and the output port as well. So for this code to be able to work with Azure IoT Hub, so under this source src folder, there's constants.h. So in the constant.h, there's Wi-Fi SSID, Wi-Fi password. But the most important thing is this one, Azure IoT connection string. So this is exactly the one that we mentioned earlier, that you need to get from the device, right? Or the one that we just created. We can copy device connection string. Okay, and then replace this. Obviously, you have to keep it a secret for this, right? So for real deployment, you have to make sure that you have to keep it secret. But yeah, but for now it's okay to show it, because after this I can just delete the IoT Hub. Yeah, I think I can just build. Then okay, succeed and upload it. Okay, it's uploading. Okay, I open the serial monitor. So the first time, it's maybe I reset it first so that you can see the actual. Sorry. So this is the whole debug message. As you can see, it's successfully connected to the access point. After that, the firmware inside the ESP32 will get the time first. This one is to connect to SMTP, and then you get to NTP. It's like, I forget, it's like time protocol something.
Network time protocol.
That's the thing, yeah. Network time protocol. So you need to get the right time from the SNTP server, NTP server, and then as you can see, initially the year is 70, is 1970. It's like a Unix time, 1 January, January 1st, 1970. So it's that means the time is not correct yet. So after that, we'll try to wait for the response from the NTP server. Then after the time is get correctly, then it will show us the actual time. I mean, this is the obviously this is the UTC GMT0, and then after that it will try to connect to the IoT Hub. If somehow the connection string is not right, it's not correct, it will reject the authentication. Since it's okay, then this, as you can see, the result is authenticated. Then after that, it will try to publish the message, right? We publish for each 10 seconds. And yeah, it's currently publishing, right? As you can see, it's currently publishing. So the question is how we can be sure that it's really published successfully. So that's why we need to be able to monitor the message from device. The message is actually successfully published, right? So for that, the one we can do from the Azure IoT Tools extension from VSCode is that we can right-click here, and then we can choose Start Monitoring Built-in Event Endpoint. Okay, so if I click this, it will open in the output. It will try to monitor, right? So as you can see, maybe I can clear the output here. It is able to pick up the message that actually sent from the device. It says dummy temperature actually, because it's actually set from here. This one, right? So this this payload that actually sending the dummy. So from this, I think you can be sure that the device working properly and connected properly. By the way, you can stop the monitoring from here, right? So it's stopping. So to start again, then you just click that. Okay, so it's still receiving. So the device still publishing.
I'm going to share my screen. Okay, I think I'm going to explain a little bit. This is the only components that are used in this project. This is the ESP Azure. If you grab it directly from here, I think you'll need to do some customization on this mix.txt file. So that's why we are bundling the ESP Azure into the repository that we send you the link. Okay, I'm uploading to. I'm already connected to the Wi-Fi. Now it is waiting for the network time protocol is set. And then it is connected. I'm going to monitor using terminal. So if you see this message, you are already connected to the IoT Hub. And then if you see this message, publish, blah, blah, and then it means that you are sending message. And then this one is some kind of the response from the Azure IoT Hub. Okay, I think I'm going to walk you through the code. So I'm going to start here using from the main.c file. So this main.c file is not that different than the one from the Wi-Fi. Mostly the same, except this one does not. This Wi-Fi init station does not wait for the event. It is now moved under this new task for the Wi-Fi connection, and then it executes this function, which actually connecting the ESP32 to Azure IoT Hub, and then sending the messages. Okay. So this in the admin, we only add this one. So now in this header, it's only just defining this one, declaring this function, which is here. So this one is, this block here is provided and used from this ESP Azure component. And then what's important here is this included in this constant.h file. And then I'm declaring this static variable for the as the memory for the message that I'm going to send to the Azure IoT Hub. And then this struct is also define the message that is being sent to the Azure IoT Hub. So it is going to be used later. And the first thing here is this connection status callback is this function will be executed whenever the connection status of the ESP32 and the Azure IoT Hub changes. For example, this one. So this one is called from here. You can see if it's changed to IoT Hub client connection authenticated, and then connection status is connection OK. So I think this will log all the events have regarding the Azure IoT Hub connectivity. And then this callback here, this send confirmation callback is, so whenever you are sending message, the Azure IoT Hub will send you the confirmation, this like acknowledgement. So the Azure IoT Hub will acknowledge whenever the message is sent. So this one here, confirmation received for message tracking ID. The result it is called here. And then it will destroy the message. So I think this one will prevent the memory leak. And then this one is, so this function here, apart from init, it's actually the one that set this initialization SMTP.
Yes.
If it fails, I think it will restart the firmware. And then if it's successful, it will try to create the Azure IoT Hub client from the connection string. So the connection string, as you can see, it's providing more than one information. It is providing you the host name of the Azure IoT Hub, and then the device ID and the shared access key, which is used for the authentication with Azure IoT Hub. And then this, you can specify the protocol, because like Mr. Andre said earlier, the Azure IoT Hub is initially supporting the AMQP, and actually you can use the AMQP using this component, but I think for now we are going to use MQTT. So if if somehow the connection string is empty, I think it will fail. This function will fail. So if it's printing error and error IoT Hub client handle is null, it's probably because the connection string is empty. So make sure you need to fill it. And then this one is setting the option, like, so this logging here, like the connection acknowledge, publish alert is enabled by here, by this line. So if you set this to false, I think you will not see these log messages. And then here we set the status connection callback, so that whenever the connection status change, the ESP32 will be notified. And then, so basically it's just for us to see the connection status. And then it will enter the forever loop. So each time every time it loops, it will try to store the current time to this structure. And then
there is 30 seconds.
Yeah, this is the 30 second time. You can change it to any interval you like, or you can move this definition to the constants file. And then, so this one is actually the line to format the message using to JSON, because JSON is the format that's supported by the Azure IoT Hub. And then this one will try to create it will try to allocate some memory for the message that we are going to send. So it will then assign the address to this message handle. If it's null, and then maybe it is running out of memory. And then this one is this IoT Hub. Then event async is for sending the actual message. And this one will, this basically tells that if there's any confirmation, then call this function. This is the function that defined earlier.
Yes.
And then we need to provide the pointer to the message structure. And if it's not okay, we'll try to print fail. If it's success, then it will try to set the time for the send, so that this will not fire. So this condition will not always be true.
Right.
So, and then if somehow the loop is breaking, I don't know, then it will try to. Oh, actually, this one is idea. The work is it will try to process the message you are trying to send, and then it will also check if there's any message coming to your ESP32. So if you try to collapse this, so it will try to always read your if there's any message left to send, or there's message coming from the Azure IoT Hub to your device, this function will check it. Then if somehow the loop breaks, we'll try to process the remaining message to make sure if there's any unsent messages coming from your ESP32 to the Azure IoT Hub. And then it will try to destroy the client handle. Then it will try to de-init the platform. I think that's the code. So I think this whole code is actually doing a quite simple task, but it's not actually that simple because it's a lot of code here.
Another thing that you can try though, in the project in GitHub, there's another project actually here, ESP32 Arduino Wi-Fi. So basically, we just want to show you that you can use Arduino framework with the ESP32.
Okay.
As you can see here, the code would be much simpler than much simpler than the one. If you remember the first day, this is your code only to connect to Wi-Fi, right? So this one only to connect with Wi-Fi.
Yeah.
Okay, but for Arduino, if you're using Arduino framework, then the code only this one, basically this one, right? And this one.
But you cannot debug that code.
We can actually
Actually,
debug.
you can. Actually, you can do that.
No, you.
Maybe Alvin, you want to show that?
Let's try.
Yeah.
So basically, the debugging experience is quite the same, but I think I'm going to start over. Let's try. So here,
Yes.
okay, we need to run. Well, it's really the same because everything is handled by PlatformIO. So now connecting to the GTEC.
Let's see. Connecting.
It's programming. Okay. So actually, the Arduino is wrapped. So the Arduino for ESP32 is actually built on top of esp-idf. As you can see here, the main function. Yeah, and this will. So this, as you can see here, I'm going to show you. So there's two functions here, setup and loop. So both setup and loop are actually part of this loop task, which is here.
Okay.
So the setup is run before the forever loop.
Okay.
Infinite loop, we call it. It's not forever loop.
So,
But one thing to note here is that all the setup and loop function is actually executed in just one core, right? Just one core of the processor there. As you can see, this I think the core number 1 there.
let's see what the init Arduino actually does. So it's actually setting the CPU frequency and all this stuff. Actually, this one or esp-idf code. So it is initializing the ESP flash, NPS flash, and it is checking the Bluetooth connection if the Bluetooth is enabled. And then if you continue, and because the Arduino for ESP32 is based on top of esp-idf, you can actually use the Arduino as the component for the esp-idf code. So you can kind of mix and match the code for esp-idf, and then you can use the Arduino code for reading sensors, because I mean there's a lot of sensors that's available, and the code is actually written for Arduino. Yes. And we did it a lot. We mix and match the esp-idf and Arduino code, and then I'm actually here. I'm stepping into the Wi-Fi task. So the Wi-Fi begin actually it connects the ESP32 to the Wi-Fi, and then it does a lot of things here. Yeah. So as you can see here, the Arduino is abstracting the tedious process of connecting the Wi-Fi, the ESP32 to Wi-Fi. For prototyping, it will definitely make the prototyping process a little bit faster, but with abstraction, there's a cost of you cannot actually take control of the internals. So if you, with the esp-idf, you have a lot more control to your firmware. With the Arduino, you have a lot more time to focus on your application.